All right, so in this lesson, we are going to talk about finding slope and what we call y-intercept from a real-world graph or table. So um, we are going to first start by defining what slope and y-intercept means. So from the last video, you should be semi-familiar with slope, but slope is the steepness of a line. So we have all different types of lines, and slope really tells us how steep a line is or how fast it changes, which is useful in many scenarios. But so we kind of learned how to do that last time. And then y-intercept is exactly how it sounds. It's where your line crosses the y-axis. So we are going to look at the starting point for graphs like these, or where it crosses the y-axis for graphs like these. So we're going to be looking at the slope and y-intercept from a graph or a table. So we also talked about last week constant of proportionality. And so you are very familiar with the constant of proportionality equation that looks like y equals kx, where k is the constant of proportionality. And in the last video, we talked about how slope is the same type of thing, but we use slope when graphs aren't proportional. So remember, that's when it passes through the point. Proportional is when they pass through the point 0, 0. So we can use y equals kx when the graph passes through 0, 0. However, sometimes our graph doesn't pass through 0, 0. Sometimes it has a starting point. So if you remember from practice 3.4, the example I talked about had somebody making $20 just by showing up to the job, and then they made $7 every hour after that. So that is important and kind of has to do with our equation. So not only do you have a slope, which but we also have to add on that starting point. So this is actually the equation for any line, even a proportional line. M stands for your slope, and the B stands for the y-intercept. So it's very similar to the equation you're kind of used to, but now we just have to account for that y-intercept. So whatever it starts at, we have to make sure to add that on to whatever our slope is. Okay, so we'll kind of come back to this idea in a minute, but I just wanted to kind of introduce it to you in this video. So our learning target for today is I can find the slope and y-intercept from a real-world situation, graph, or a table. So if you look, we're going to start. I'm going to show you how to find slopes from graphs, and then we're going to look at some tables, and then we're going to look at some equations and just identifying slope and y-intercept. So let's start by doing the graphs first. So if you look at this example here, we talked in our last video, slope. To find any slope, we have to do the change in y over the change in x. Okay, and the triangles just mean change. So I have to figure out how my y values are changing and how my x values are changing. The easiest way I know how to do this is to make a table. So I'm going to make a value of x, y tables. And so I'll just read off my points. So this one is 1, 5. I have 2, 10. And I really only need 2 points to find the slope of the line, but I'll keep going. 3, 15. And so to find how my y values are changing, I know that it looks like my y values are increasing by 5, and my x values are increasing by 1. So the change in y is 5, and the change in x is 1. I know 5 divided by 1 is 5. So that means I'm going 5 miles per day. So that's our unit rate. Okay, so my slope of this line is 5 miles per day. And my y-intercept is wherever my graph crosses this y-axis. So if you look, my red line doesn't necessarily cross my y-axis in this example, but I'm going to extend the line so that it does. So if I continue my pattern, Okay, I want to know where when my graph hits the y-axis, my x-coordinate will be 0. So I really want to know what my y-coordinate is when my x-coordinate is 0. So if I continue this graph, my other point would be somewhere right there at 0, 0. And so I could extend that line there. And if I continue the pattern too, I would go 5 back and I would get 0. So my y-intercept for this would be 0. And we're going to look at some other examples as we go that don't have a y-intercept of 0. But that's how we can identify it from a graph. We're looking at where it crosses that y-axis there. Okay, let's look at another example. So this one is similar. So what I'm going to do is make a table of points. So I can just choose any of these here. I want to choose one that cross the grid lines nicely. So this is 250. This is an x coordinate. This is a y coordinate. And then I can also choose like 4, 500. So 2 points is all I need. If I want to, there's also, when I'm looking at graphs, what we call rise over run. And so that just means, I'll kind of show you in a minute. So hold on. So we'll keep going with this. If I want to see how my y values are changing, well, they're increasing by 250 on this side, and they're increasing by 2 on this side. So if I want to find my change in y over my change in x, my y values are changing by 250, and my x values are changing by 2. So to find the slope, I just have to do 250 divided by 2, which is 125. So my slope for this is 125, and that is meals packed per hour. So slope is 125 meals per hour. And real quick, my y-intercept here is wherever this line hits the y-axis, which you can see right here is 0, 0. So again, my y-intercept is 0 here. My starting point is 0. So another way to tell slope without making a table is to use what we call rise over run. So sometimes you'll hear change in y over change in x, or you'll see rise over run. So rise over run is just like thinking your y values are up and down, so that's your rise. And your x values are your left to right, that's your run. So if somebody was running, they'd go left to right. If somebody was rising, they'd go up and down. So if you look, I'm looking at the change. This red part here says from 0 to 250, and from 250, and this point looks like it's 875. So there's a couple points here. So if you look, each box is worth 125. It goes up by 125. So if I rise 2 boxes, I'm actually going up 250 here. And I'm running 2 spaces on this x-axis because it's counting by ones. So I'm running a positive 2. On this blue, I'm rising, let's see, 250 plus 250 is 500 plus another 175. So is 625. So I'm actually rising 625. I just counted all the boxes. They're going up by 125. And then I'm going over 1, 2, 3, 4, 5. I'm running 5. So for this red triangle here, my rise over run is 250 over 2. And my blue triangle is 625 over 5, which if I do those, if I divide both those numbers, I get 125 for both. So it doesn't matter what 2 points you look between, because when you divide those changes in x and changes in y, you're going to get the same number because this is linear and it's going up by the same thing every time. So that's another way you might hear slope done or explained is rise over run. Just looking at the graph and kind of looking at how much you're rising and how much you're running from 2 points. All right, a couple more examples here. These will be quicker. I personally like the table method because you're less likely to make a mistake. So you can do the rise run method from this point to this point, and you go up 1. To get from this point to this point, you go up 1 and you go 1, 2, 3, 4 over. But I'm actually going -4 over because I'm going to the left. And sometimes people will forget to add that negative, so they won't have a negative slope. But this line is a negative line because it's going down from left to right. So you need that negative there to indicate that. So I always like to write my points in a table because you're less likely to forget that negative. So this point right here is 0, -1. And then this other point right here is -1, 2, 3, 4. This one is -4, 0. So if you look, if I find my change in y, I'm actually going up 1. From -1 to 0 is up 1. And then on this side, I'm subtracting 4. So my change in y divided by my change in x is 1 over -4. And I'm going to ask you to leave slope as fraction, so it's -1/4. And my slope for this is -1/4, which means I'm rising -1 and running 4 if we're looking at it in that terms. Your y-intercept for graphs like these are anywhere your line crosses your y-axis. So my y-axis is that green right there. So the place where my graph crosses that is that point right there, which is -1. So my y-intercept is -1. Okay. And so my example over here to the right, again, you could do rise over run, but I'm actually going to make this table to make it more accurate. So that point down there is -3, -1. Other point is 3, 3. So now once I have those points listed, I can find how my y's are changing. So -1 to 3 is +4. -3 to 3 is +6. So my change in y over my change in x is 4 over 6, which I'm going to reduce. I'm not going to divide. I can divide both the numerator and the denominator by 2. So I end up getting 2/3 as my slope, and that's a positive line, so my slope should be positive. And then my y-intercept is wherever that blue line crosses my y-axis, which is right here, and that is +1. So my y-intercept is +1 here. Okay, so that is how you can find slope and y-intercept in an equation, or in a graph. And so there's 4 examples there.